Right, hello and welcome to the channel. And today is the big one. I was planning to do this video for a really long time. So my plan was to do a Clojure crash course 2024, last year, but the entire year passed by and I haven't recorded the video. So it's still beginning of 2025, so I thought I'll finally do it. On my channel, regarding the Clojure content, I was more focusing on providing real-world examples, maybe some more advanced topics. And today I want to fix that and finally provide some Clojure beginner-friendly content. So it will be quite long video, I suppose. I'll cover the basics of the language, of the development environment. So I hope this will be quite useful for people looking to start with Clojure in 2025. If you're an experienced Clojure developer, I don't expect you'll learn much from this video, but for the beginners, I hope it will be really useful. So I have a rough plan for the video and see how it goes, but we will cover topics like how you get started, how you configure your editors, which is really important. Then we cover the ideas of REPL-driven development and do this quick feedback from the language in your development workflow. Then we cover Lisp basics and Clojure language basics, collections and data structures, some core library functions that's most commonly used. Then we'll talk about Java interop, which is critical for Clojure because it's a hosted language and we have the entire access to the entire ecosystem in Java, which is really powerful. And yeah, pretty much that's it. And I'll provide some future steps that you can take in your learning journey. So without further ado, let's get started. And the first topic is how you even get started with Clojure, what you need. And as I said, Clojure is a hosted language. I'll be focusing on the main implementation, which is Java runtime. There's also Clojure script, which is on JavaScript runtime, another popular hosted variant of Clojure, but it's out of the scope of this video. So for that, you will need Java, and I suggest pick one of the recent versions, like Java 11 will be fine, but nothing wrong if you go 17 or 21. It all works with like Clojure versions. So you can install it on your own. You should have Java on your machine. So for me, I'm using Java 17 OpenJDK. But as I said, it doesn't really matter. You can pick whatever you want. Then we will use Leiningen as a build tool for Clojure. You can think about that as Maven in Clojure world. It will provide you a way to define your dependencies, where to look for your source code, where you look for your tests, and it also provides some nice developer-friendly CLI API to run your code, to build your code into jar files, and also to run the tests. And actually, it could be extended with plugins, so it can do much more. I know that nowadays there was a lot of effort by Clojure team to create Clojure CLI, and there's things called dept.edn that potentially will eventually replace Leiningen. But for the beginners, I really recommend to ignore this bit for now and just focus on a simple tool that will do and will cover most of your day-to-day tasks regarding building projects in Clojure. And also don't feel that you are doing something wrong because Leiningen is still really popular even if you're doing production development in Clojure. We have like 100 microservices, most of them, 99%, still using Leiningen, so it's completely fine to do so. So this is the link. You can just follow the instructions how you install it and you'll be ready to go. For me, I have len and I can do len- version that shows me what version I'm using. So to create the project, let's go up one level. You need to run lane new app and then your project name. For me, it was Clojure Crash Course. And when you run that, it will create a new folder with this name, and it will create a app template. It will basically use some kind of template that will good enough for beginners. Let's go inside and see what we have. Clojure Crash Course. I can run tree, and this is the structure what I have. The project CLJ is the file where you define all your dependencies, as I said, kind of like an entry point of your repository. Then we have src, where you put your Clojure files for the source code, and then you have test, where you put your code for tests, obviously. And there's usually a convention that you have your namespace, and if you want to test functions from that namespace, you create the same name with test at the end, and you put test code inside here. But we'll take a look into that in a sec. So, and that's it, basically. You can ignore the rest of this. We can actually even remove the doc folder, so we have more clean structure. And about the API, so the first command you need to know is lane run, and it will run the main function of your Clojure program. So let's run this. It says hello world, and it is searching for the main function. So if you go into your core namespace, you see this defn main, and this is what actually called when you call the lane run. We'll talk about the syntax and all that stuff later in the video, so don't worry about that for now. This is basically a doc string that we don't need. I can remove that. And also we don't use any arguments in our run command, so you can remove that as well. So this is print line, what is printing. We can change it here. So let's say Clojure Crash Course 2025. And if I go back here, I can run my command as well. And now we have the different print line. So after this, you basically can start experimenting with the code after the video with this template, and you can have an easy way to run it. But also we'll take a look how to configure a better developer experience by using REPL-driven development in the next chapter. So the next thing you want is lane uberjar, and this command is to build your jar file from your Clojure code. So now you can see that there's a new folder created, which is target. So I can run tree again. And now we can see that we have this target and then uberjar. And inside we have the standalone uberjar. And basically, when you're using this thing, you don't even need to care about Clojure anymore, because it's just Java code inside. And you can use this jar, for example, to build your Docker image on the Java runtime. And at this point, as I said, there's nothing related to Clojure. You already converted into Java. Next, we have lane test, and it will run test. For now, we have only one in the core namespace. By default, it's in failing state, but we can go inside our code, test, then here, and we can fix it. So this is an assertion. We can say 1 equals to 1. That's our assertion of the test. We can rerun that, and it should be all good now. So 0 failures, 0 errors. All right. That's how you generate the project, how you use some basic commands to run the application, to run tests, and to build the jar file. Let's see what we have next. Then let's talk briefly about editors. So for beginners, I recommend two options. First one is completely free, which is VS Code, really popular editor, right? Like a lot of people using that. And there's a really nice Clojure plugin called Calva. This is the link. You can install it in VS Code, works really well. And as I said, fully free, both tools. The other option is IntelliJ, which is what I'm using right now, and cursive. So, and here it's a bit tricky because you can use IntelliJ Community Edition, which is free, and then you can use cursive for free for educational purposes. But if you want to use it for commercial development, you will need at least cursive license. But also, a lot of people enjoy IntelliJ, and I think IntelliJ Ultimate is really a nice package of features. So for me, I have IntelliJ IDEA Ultimate, which is paid thing, and also I have cursive, but actually I have my license from work. So I have both tools paid with the license. But as I said again, if you're just learning, nothing should stop you to use IntelliJ and cursive and use both free licenses like community version of IntelliJ and free educational cursive license. Next we have Emacs and Neobeam and all that fancy editors. The only thing I would say is that if you're not already an Emacs or Neobeam power user, don't start your Clojure journey at the same time you're trying to learn Emacs, for example, because it will just slow down you. You'll be really frustrated by configuring and fighting the editor, and at the end, you better spend time learning the language and not fighting the editor, right? I'm not saying this is bad. Like Cider, for example, the Clojure support in Cider for Emacs is a really nice tool. And there's a lot of effort put inside this. And like Emacs is configured by some kind of Lisp. So like one of the reasons why it's really popular in Clojure community, because you can write configuration in the same Lisp as you write your main code. But yeah, as I said, for beginners, just ignore that if you're not already familiar with the editors and start with these two options. For me, I'm using IDEA, so all the examples here you'll see for the IDEA, but you'll have the same features from Calva and VS Code as well. Right, so now we have our application opened in the editor, and if you have your plugin installed, so for me it is, go to plugins, and then you see this cursive installed right here. When you have that installed, your files for Clojure files will be automatically detected. It will also understand that you have Leiningen configured as your build tool, and on the right hand side you can see this Leiningen. You can refresh your dependencies, for example, right here, and it will pull your new dependencies as you add them in your project automatically. Then the critical button is right here, REPL. Should be pre-configured in the recent versions of the cursive. So the only thing you need to do is to click this Run REPL button, and let's see what happens. So Java is known for its slow start, and by using REPL, we are trying to eliminate that problem. Because now we start our JVM once, and then we kind of live inside that runtime, and we can reload our code really quickly, and we can just execute it instantly. And also we can just have a really quick feedback. So in addition to your files where you write your code, you have now this additional window here where you can experiment with any code you want. So let's say some basic stuff like plus 1 and 2. So this is an expression in Lisp that will sum two elements, right? And I can just hit enter and I see the result of that expression. And it's not just that. So this REPL thing exists in a lot of languages, but the amount of features you have and the deep integration into your editor is what makes Clojure ecosystem different from other languages. So you can print something, for example, print line here, hello, it is printing it to their standard output. You can define your vars like this, and you have access to that. So we'll cover that later. And also, you can also switch to namespaces here. So this is the file source code. Now my REPL is connected to this namespace, and I can, for example, call the function that exists in this namespace. So I just call the main function here, you see, and I have the print line inside. You can define a new function, for example, let's say some test fan, no args, and it will return, for example, string test. I can evaluate that, and I can run my test fn, and it prints it back to me. So you probably can see the power of that. You can literally jump to any bit of your code, even in a complex project, switch to that namespace, and experiment with the code that you have straight away. All right, so that's the REPL. We'll see more of that during our video. Next thing I want to briefly cover is these modules that we have, or in Clojure we call them namespaces. So for now, you can just remember a simple rule. You have your source file folder right here, src by default. Then you have your top folder, which is your top namespace name. And all the files that have this CLJ extension will need a definition of the namespace at the top. We actually don't need this gen class here, I think, but the simple one, let's create a new one. So we have new Clojure namespace, and let's say example. We can add it to Git, and as you can see, a new file created here. If I go here, Cursive automatically created this line for me. NS stands for namespace, and then the name of it. And the convention is that the folders, if you go deeper level, is the dot here. For the tree structure, it's the top name, then the other name. If you want a new package, you can do that. So let's say package, I don't know, like common, and you now have the extra folder, and then you can create a new namespace. Let's say Clojure namespace, utils, something like that. So you see the pattern, right? So now we have our top level here, then dot common dot utils. And if you, for example, want to use one thing you need to remember is that if you have dashes here in the name on the file system, that should be underscores. I believe that's some kind of Java Maven limitation kind of thing, but I don't really remember. But yeah, that's the only inconvenience. You cannot have dashes here as well. But in Clojure, the main naming convention or format is kebab case, which is called like the thing that when you have these dashes in between, stuff like that. So you can stick with the format, but actually nothing stops you to, for example, use underscores for the names. It will be still valid, or even if you prefer, you can use how it's called, camel case, stuff like that. That will work as well. So the next thing is if we go back to our core namespace, let's say in our utils function we created a new one. Let's say we have an add function having 2 arguments, and it will return the sum of that. Don't worry about all this syntax, we'll cover that. I just want to show you how to use different modules and different functions from those modules. So we have defined this add function in a different namespace. If we go now to our core one, we can use require keyword right here. The syntax is like that, and then you put your namespace, and you say it can add an alias, let's say utils, like this, And now you're linked to namespaces. So you now have access to the functions defined in this utils namespace from the other namespace. So let's say we have this print line. Let's actually do something silly. Let's do this. Clojure course, and then we do utils. As you can see, we now have access to our new function that we added in the different namespace. And let's say we want add 2025. Let's reload this. And I can now call main again. And we have the same result. I don't need this space anymore. Let's run this. And of course, we can go back and run our application from here as well. Cool. So that was how you define namespaces and how you link them together if you want. So finally, we're ready to talk about Clojure language itself. And the first thing you need to know, or you probably already know, that Clojure is the Lisp dialect. So the syntax is Lisp. And what that means is, it means if you go from popular languages like normal languages like Java, Python, this Lisp notation will look really weird to you, and you can have questions like why you use things like that. But after you work a bit with Lisp syntax, I promise you will really enjoy it. And I personally think that it's the most convenient way to express your thoughts while you do coding. So the rule is really simple. You always open your bracket. And for me, the editor auto-closed my bracket. So you open the bracket, then you have your function you want to call or some operation. For example, you can say plus, or you can say print, or you can say, I don't know, even, which is a function from the core namespace. But let's stick with simple arithmetic operation now. So plus, right? And then you have your arguments. It could be one or more. 1, 3, 4. You evaluate that, you have the sum of that, right? So what's the difference? In the normal way of writing, you need to write the operator multiple times in between. So one of the benefits of this notation, which is sometimes called a normal Polish notation, I believe, NPN, is that you kind of save on typing when you don't have to repeat yourself. And also, you basically just learn the entire Clojure syntax, right, or Lisp syntax. You have your S expression, which is like things that goes in between the curly braces. No, how's it called? Parentheses, right? And then you have operator or function, and then you have multiple arguments. Nothing else. Clojure adds a bit of extra things. So, for example, we have square brackets to defining vectors. We'll cover that later. We have curly braces to define maps. And we have this special way of defining sets. But other than that, if you combine all of that, you kind of know the entire Clojure syntax. You obviously need to learn some semantics. For example, what if you have like an if statement, for example, what you put, how you structure that. But when you look into that, so for example, let's say if 1 equal 2, if 1 equal 2, I want to say false or do something. So this is if statement. Then we have the condition, which is the first argument of this if operator or macro, whatever. And then we have the first branch and have the second branch. And this, for now, it just like evaluates the string, right? But we can nest it, right? So we can do something inside here, or we can do something inside here, or call some other function. Let's say call something else. So you're getting the idea, right? If you forgot about that, we need to understand what this if means, right? We still have the same S expressions combined into a bigger one, and that's really convenient. So let's see a couple examples. So this is a normal arithmetic expression like 5 minus 6 multiplied by 7. If we want to write that in a Lisp way, we'll do something like multiply, then the first result, it will be minus 5, 6, and then we multiply it by 7. So to evaluate that, we can do this. If we go step by step, 5 minus 6 will be minus 1, multiplied by 7 will be minus 7, what we just seen now. Let's convert something like this, for example. So what we have, the top one is plus. Let's say we have, no, actually we need to do minus first, right? So it will be minus, and then the first thing will be plus, and it will be 7 and 5. So we covered this bit, and then we want to extract the result of this multiplication, right? So we put it right here as the second argument to minus, and we just use the multiply, and then 8, 3, 5, or other order if we want. So I think that's a really nice way to make sure you understand this notation, and arithmetic expressions will be really handy for you to practice. So if you just ask ChatGPT or something to generate you like 10 examples of nested arithmetic expressions, and then try yourself to convert it into a Lisp way of expressing things, and then you can evaluate that in REPL and make sure that it's actually matching the example that you trying to convert, right? And then you can even go to your test file here. Let's say you're getting this expression, you're copying that, putting it here as the first argument, and then, or it actually should be the second argument because the first one is expected value. Let's say I put here minus 108. If I go here, I can run the test. It says no failures. If I have a wrong value here, you'll see the failure. So it will be a nice way for you to get starting with tests, and also you can try rewriting your expressions into Lisp. Cool, that's covered. Next one, defining global vars and primitives in Clojure. So let's go to our core namespace. I think we saw something already. So let's say we have this def keyword for the defining vars, right? And the other thing is the next argument you need is the var name. So let's say we have our var a, could be anything like hello, something, whatever you want. It's like same as doing like int something in Java, right? So it will be var a, and it should hold a value, right? So it could be 1 as an integer, some other integer. It could be a string. It could be like float or double. So those are ways to defining things in Clojure. You have this def keyword. You can evaluate that, and then in the REPL you can do var a. I need to jump into this namespace. You have access to var a if you just call it. Then we have functions, right? So there's a fn, which is a macro. You don't have to understand what that means, but basically fn will allow you to create a function. So the syntax is this: you open your square brackets for the vector, and this will be your arguments. It could be empty, so let's start with an empty one. And here you provide your function body, and it could be any set of Lisp S expressions. At the end, it should be evaluated to something. So there is no concept of early returns in Lisp, or I'm not sure about Lisp, but in Clojure, there's no idea of early returns. So you cannot do something like if some condition return. It should always be the last result of your evaluation. So you can do something like some operation like 1 plus 2, and then return calculated. This function will evaluate this and then return the string, right? You won't ever see the result of this expression, but you can do something like println, and then you can see the result of 1 plus 2, and calculated will be returned. So you'll need a bit of practice to understanding what is actually returned, like how that all works. But yeah, I don't have any quick way of explaining it to you other than just go and practice. So that's the function, right? Let's actually call that, right? But now our fn will just create a function. We need to assign that function to some var, right? The way of doing that is you do def and then say my fn, which is the same pattern as you can see here, right? It's the var name, but inside the value we now have a function inside, right? So let's evaluate this and now call my fn. We see that 3 was printed, and then we have this return from the function. Let's actually change it now to something else. Let's say we have we want to implement add function that will add two integers, right? X and y, right? Now we want just to return the result, right? And what we want to do is plus x and y. We'll evaluate that, call add 1 and 2. We have 3 as the result. So you won't see this way of defining functions a lot in Clojure because there's a shorter way, and that's defn. From the name you can see it's combination of def and fn, and it's what literally is going inside. Now you don't need to use fn. Now this all, how you convert it basically to defn way. You pick this block, which is anonymous function, then you change fn to defn, and then here between your args and the defn you put your function name. So it will be add now, right? I can remove this, evaluate this, and now I can call my function again, 2 and 3. Result 5. All right, so that's functions and global var definitions. Let's see what we have next. This could be a bit tricky for beginners of Lisp and Clojure because a lot of things are immutable in Clojure, so you cannot do something like int I equals 0 and then do I plus plus or I equals I plus 10 and mutate the value inside. Instead, you need to understand how you define your variables inside a function, for example, and how you define your scopes. And for that, we have the let block. So let's say here we want open a new scope, and we do it with let, and then we have the vector, and then we have, let's say, A1, right? So now this opens a new block right here, it's again the same as expression as you've seen before, but now we can do something with inside this scope, and we will have access to our a var, right? So if I do print line a here and evaluate that, you see that we have 1 printed at the end. But if you want to access a outside of the scope, like this, you see we have an exception that a is not in the context because it was never defined. And that's the difference between scopes and like global vars, right? But what we can also do is that we can nest this, right? We can do let, and let's say a again. Now we say 10, and we do print line a, and we call this again when we see 1 and 10, right? This is because we opened a new scope right here, and the value is shadowed, like it's called shadowing. So in the first scope we have a equals to 1. That's why we have this print showing 1, and here we have 10 again. But the interesting thing is that if you leaving the scope, but you still have has this a defined in the top level scope, you can do print again and print a, and as you probably imagine, this will print 1, 10, 1, because now we almost forgetting about this scope in a nested scope, and we just back to the original value of a. If you have a function that's doing something and you want to store the result of the execution, let's say we say it to be a result of add function call 1 and 3, and we want to print that. So the result of the function could be assigned to a let var. If I call this, we have 3. And let blocks are really convenient because you don't have to have a single let block for defining multiple things. So you can do something like this. Let's say you define multiple vars. Let's say x1, y2. And then here you can refer to them. So x plus y will be the result. And then you can say something like print line result of adding x and y equals result. And yeah, you see we have access to x, we have access to y, we have access to result, and that all lives inside a single scope. So that was let block. Let's see what we want to cover next. So yeah, now we're jumping into data structures. Clojure is dynamically typed language, so you don't need to create classes. You don't need to define your types ahead of time. And how we create collections. So there are 3 or 4 main things you can do. First one is vector. It is square brackets. Inside you can put things. It will be a sequence. You can think about that as array list. You can evaluate that. You can see you now have a vector of 3 items. You call it function type on top of that. It will give you a persistent vector. This is the internal type that Clojure uses for the vectors. So for example, you can have access to the index of that. So get from vector at the index 0 will give you 1. It will give you 2 if you call the first one, and it will give you exception. Oh no, actually it's nil if you getting the out of index. Alright, so that's the way you work with vectors. Then we have maps. It is a dictionary, basically, a hash map. So the way you can look at this, you need to have even number of entries, because you partition that by 2, and that's your key value pair. So you can use whatever you want as the key. Let's say we want strings. So the map will hold a key string A and the value 1. You can put commas here for readability. Not much people doing that. That's our second pair, right? So now we defined a map that will contain 2 entries. This is first key value pair. This is the second key value pair. The thing that you can nest that. So for example, you want a vector as the value of the first key. You can do that. You don't have to keep the same type of your keys. So you can have the second pair, which will have the key as integer. You can go even crazier. You can have a vector or even another map as the key, right? So you can do whatever you want in Clojure, really, to model your data like this. So in this case, we have 3 entries. The first key is A, the second key is 1, the third key is actually a map of 1 to 2. And yeah, it's really handy. So next thing we have is set, which is same curly braces as the map, but you add this hash symbol before that, and that's basically a distinct collection of elements, hash set, things like that. So you can do 1, 2, 3. You have your elements. I think if you add 3 again and you try to evaluate that, you'll have an exception that you have duplicated key. But also you can do something like set from the vector. In that case, yeah, in that case, let's see if I add a duplicate here. Yeah, if you convert it this way, that duplicated key will be removed. So what we can do with our collections, we can learn some core functions that you need to work with collections. Things like map, filter, remove, group by count and frequencies. There's more, like we can probably cover reduce as well. So let's copy this into our core namespace and we'll go through all those functions. I also have a handy video on the channel called something like 50 Clojure functions in 50 minutes, which will probably give you a better understanding of all the things you can do in Clojure. But for beginners, let's say we'll work mostly with a vector. And let's say we have our vector v, and we have a vector of 3, maybe 5 elements, right? So first one is map, and map is in a simple way. You go over your collection and then you apply a function on each of the values. You can define whatever function you want to apply, and the result will be same vector, but that function will be applied to each of those elements. Let's say we want to increment all the values inside our vector. We can do something like map, and then we define fn, anonymous function, what we want to do on top of each element. Let's call it element here. The names is what you define. It's up to you how you name things. And here you can use increment function, or for simplicity here I'll just do element plus 1. And after that we provide vector right here. We call this, yeah, we need to create our vector first. We call this, and as you can see, we have a collection now with 2, 3, 4, etc., which is original vector, elements incremented by 1. You see it as not as a vector, is because there is a concept of sequence or list, and when you see this parenthesis, it's now a list, not a vector. It's more like a doubly linked list, I believe. If you want a vector, you can use map. You can use map v instead. It will convert it to vector at the end. So that's the map. It's much more than that, because you can apply map to multiple input collections. So let's say we have v, but then, for example, let's say we have we basically now applying map over two streams, two collections. They could be different, right? If we had like another vector, we can use that here. But for now, our map will be applied to both elements, and now our function inside the map should accept both arguments. So it will be element 1 and element 2, and now we want to, let's say, sum those two together, e1 and e2. Let's evaluate that, and as you can see, that now will be 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, etc. And that's the result. I understand, yeah, it couldn't be clear right now what's going on, but I really suggest you just go and practice on your own. That's really the only way to learn. I can just show you basics, but yeah, the rest is on you, really. So that was map. Next we have filter, and the filter is the way you remove elements, obviously, from your collection. Let's say we want to filter our v vector, right? Filter v, and in between we create a function where we define the condition what we want to filter by. So again, we have this element e, and let's say we'll use the function even. So even of 1 is false, even of 2 is true. So it basically tells us which element is even or not. And here we can call even e. And by the result of this, we should see 2 and 4. And that's what we have, right? And also, I'll just show you a shorter way of doing this. If that's the only function that you call, instead of creating this layer of another anonymous function, you can just copy this, put it right here, and it will work the same way. Because this function is already accepting a single element, and it just returns true or false. And that's what we want for our filter fn. And that's a smarter way of writing the same thing, right? Cool. Moving next, remove. Remove is opposite for the filter, really. So we provide the predicate. If the predicate is true, this element will be removed from the list. So we can do the same idea here. Fn e, remove if it's even. E, in our vector. Let's call this. Now we removed even numbers from our list. Again, same trick. You can do this. Remove our fn. Call this. It's still the same. So then we have reduce, which I believe a lot of beginners have some problems with. And also I can tell you that this map, filter, remove, group by, etc. covers most of the needs. So reduce is used not too often, so don't worry about that too much. But basically it's like one of the most generic ways how you can handle the collection. So you provide a function, and in the function you will have a thing called accumulator, which will be your result at the end of reduce. And then you have access to your element as the next one. And then there are two ways. One is when you provide initial value and one when you don't. In case you don't provide initial value, your first element from your collection will be your initial value. But let's say we, for simplicity, will provide initial value in this example. So it is function, then let's say initial value 0, and then our collection. And the last thing we want is we want to implement our reduce logic. So again, for simplicity, we just want to add accumulator to the element. What we're doing here is basically we're summing all the elements from our vector. Let's see. You can check, but I believe this the sum of 1, 2, 3 to 5. So obviously there's a more handy way of doing that. So there's a sum, or like you can basically apply plus to the vector, which will be the same result. But the power of reduce is that you can basically implement whatever you want here, right? You can, for example, say that your accumulator is the vector, and now you can concatenate the vector, the accumulator, with the element, and let's say you want to double the element, and you want to combine that into a result vector. Let's see if that works. So yeah, so now what happened is we have an empty vector as our accumulator. Then we receive the first element, which is 1. We double it, and we add it inside the vector. So on the first step, accumulator will be just a vector of one element here, which is 2. And actually we can practice a bit here, and we can show that. So let's say we open our remember our scope block, and let's call it result of this one. And the way I'm doing it like so is because I want to print it first. So I'll do println result, and then I'm returning the result right here. So the output will be the same, but at each step the reduce was applied. We'll see intermediate result right now, hopefully. So yeah, you see this tree printed. That was our first iteration, second iteration, third iteration, etc. So moving next, group by, really nice function if you really handy and really used a lot. Let's say we want to group by some predicate. Again, we have this element. If this returns something, it shouldn't be even true or false. It could be could return anything. That will create a new group, and if the other element returns the same value, it will be added to that group. So for our case, we again will use the even function, even e. We are grouping basically by the property of the element, is it even or not. So the result map will have 2 elements with keys true and false, but you can extend it to whatever you want, really. So even e is our predicate for group by, and we provide v. We call this, and we see we created a map. False is basically even false. 1, 2, 3, 1, 3, 5. True, 2 and 4. Again, same applied. And do this, and oops, evaluate that. Same result. Count, really simple. Just count the elements in the vector. And frequencies is really a nice one. I really love this one. So frequencies of v. It's quite boring, but basically it calculates the count of each element in the list. So if we had something else, so for example 1, 2, 3, and then like rest is a couple of ones, it will be 1 to 5, which is like counter how much time you've seen 1 in the list. Right, so this is kind of like random subset of functions available in Clojure core. You can go inside, list all functions available in Clojure core, and scroll through them, and just read the docs and trying to apply them. There are a lot of things going on, and a lot of handy functions that work with collections. And it's pretty cool that most of them work on any type of collection. So that's the power of having a lot of functions working with a small number of collections, which is really useful. I think we really getting to the end. Let's see what we have left. So yeah, Java interop. Really quickly, but that's one of the reasons Clojure is strong and growing, is because the decision of building it as a hosted language with Java. Java is pretty popular, and I think it's a really nice platform, and the collection of the libraries available is really nice. So you can basically access any Java library from a Clojure code without too much problems. So let's see what we want to cover. Static methods, constructors, and object methods, right? So let's go here, put it right here. So static methods is, let's say, for example, want integer. And if you want to call static method on integer class, you do it with slash. And I believe there's parse int, for example. So it will parse integer from a string. You go inside, you see this notation, it's public static int method. That's how you call static methods. Then if you want to create something, like call Java class constructor, you do, for example, string, and you put this dot at the end. You just need to learn that. You go inside, you're getting the definition of the constructor. So I think for string, you can probably do something like this, right? Oops. Let's call this. Yeah, we now created a string. We didn't have to do that because just this will be a string in Clojure. I'm just showing you how to create an object in with Java interop with a constructor. If your constructor takes multiple arguments, you just put them here as second argument. And the next one is calling the instant method, right? Let's see what we have. I think this int value, yeah, it is instance method, not as static method. So what we can do is, let's say, def I, and then we define our integer. So now we have access to our I right here. And if you want to call any static, any instance method on that, now you prefix your method with dot instead of constructor where it was at the end, and we can do int value, one of the methods, from I, and that's how it works. So this is how you call instant method on Java instance. Basically, that's pretty much you need to know about Java interop. Yeah, I think that's it. So let's briefly look inside project CLJ as we skip that. So the main section you're interested in is these dependencies. And as you can see, for now, we just have Clojure. And this is because Clojure is just a Java library itself. And you can provide a version right here. If you want any Java library, you can add it here. The way you do that, you do something like what do we want? AWS Java SDK Maven. You go to your normal Maven repository like this, latest version, whatever. And here, for example, for Maven, it will look like this, but there's usually the line again as well, and it's much shorter. So you copy that, paste it right here, and then you just import your changes, and it will pull the dependency, and now you can access this Java library from your code. And that's it, really. So finally, the last one is a bit about concurrency. And you, like the bare minimum, what you can start using is futures and atoms. So let's see an example. If I open the future block, it will now execute what's inside in a separate thread. So to demonstrate that, let's call thread sleep, and then let's say 1 second, and let's say print len hi from thread. And in addition to that, I just want to wrap that in a do block, and right after the future, I want to create a new print line saying end. And what will happen now is that we will fire a new thread, but that will sleep for a second. So this print will be delayed, and then we have a print line here. I just want to demonstrate you that it's actually not blocking the main thread from where I'm calling it. So it will print end, and after 1 second it will print this from the thread. As you can see, end, and after delay we have this print line. So that's really easy. That's how you start a new thread, a concurrent thread, and a parallel thread in Clojure. The other thing is that when you have multiple threads, you need a way, an atomic way to update some values, right? Or how threads can exchange information. And there are multiple ways how you can do that. There's like a CSP-inspired library called CoreSync for implementation of something similar to Go channels and Go routines. But the other thing is you want to understand is that you can use atoms. And let's say I have an atom A. You use this function atom, and then you put something that holds the value inside. Like the atom is kind of container, and you put whatever you want inside. So for example, you want 0 as an integer. You can do this, and after that you can use swap command, swap function, to update the value. So it will be update A incrementally. You can call this, and the beauty of this is that you can do future increment like this, and future increment here. Let's do block. I can call this. It will create 2 threads, and after that I can do deref of atom A to get the value. It is 4, but actually let's reset it to 0. Now 4, and if I call this and I get the value, it should be 2. And the beauty of this operation swap is basically it guarantees you atomicity, so there's no race conditions. This increment operation will be applied exactly once to this atom value. So that's one of the ways you deal with concurrency, by using atoms and future and threads. There's also, like, if you do some map operation and it's specifically CPU heavy, so you do a lot of calculation, you can get a benefit of concurrent calculation, parallel calculation, by just using pmap. So here, if you switch map to pmap, this function here will be applied on separate threads, which will increase the performance. But use that carefully, because this intended to be efficient only for CPU heavy threads, heavy tasks. If you have I/O, you'll block pretty quickly the available threads. But there are other ways of doing the I/O operations on the thread pools. So one of the ways is to use a library, the Claypool library, which is a really handy wrapper on top of the Java executor framework. So you can use pmap versions from there, but you can provide a separate thread pool to run on top. but that's definitely out of the scope of this video. But really, that's the end of the video. I'm not sure how long it took, but I'm feeling it was quite long. What are the next steps? What I can recommend? I think I've done pretty decent job on the channel, creating some high quality Clojure content. So I really recommend checking a lot other videos on the channel. There is real world examples how you build microservices, covering all the tests and structuring like the library choices, etc. So that's really useful. Regarding books, I was learning Clojure maybe 9 years ago or something like that. So I enjoyed the Clojure for Brave and True. Just skip the Emacs entry chapter. The rest of the book is really entertaining. Still pretty decent choice, I think, if you want to more structured way. Then I heard good things about Living Clojure. But basically, if you just search for Clojure books, there'll be decent options if you want some kind of structured knowledge. The other thing I recommend is you just create your Learning project and, for example, try building some simple REST API. There are libraries available, and you can learn a lot about the language and about building the services. And the other thing I forgot to mention here is what actually really helped me when I was learning Clojure is the website called For Clojure. The original version of that was actually deprecated and turned off, but there's a read-only version available. So you just search for Clojure. You'll have access to all the tasks that was in the original website with all the answers. So it's not like a lead code kind of questions, but you need to fill some gaps in the statements so they evaluate to true. And I remember it to be really helpful in learning a lot of things Clojure related. So yeah, I guess here I'll stop. And please really like this video and comment. That really helps with YouTube promotions. Let me know what you think. What should I cover next? Good luck with your Clojure journey, and see you next video. Bye bye.